greatest integer function. This is the parent function as we did before evaluating the parent function we did in the previous videos. Now we are going to see some of the functions that are in a family of the parent function of the integer functions. Let's see, we have a f of x is equal with the denotation of a greatest integers plus x or plus 3. So what we are doing here, here we are going to do same thing what we are doing how we are transforming linear function, quadratic function, cubic function, etc. We already know this parent function and we are relying just in this part here, just in this step. When we find one step, the rest of the step we find very easy. For example, the first step in parent function was closed and open. But now this closed and open is going to move vertically 3 units up. 1 unit, 2, 3 units up. And this is a closed here, and the other is open. And now here is a closed, and here this pattern continues in the left side and the right side of the graph. So it's very easy. Closed, open. Same thing goes this way. Here is a closed, open, I'm sorry, and the other side is closed. Here is a open, open, and in the other side is closed. Same thing, this continues, open, and goes here closed. So this continues forever, but I think this is enough elements that I am drawing here in the graph. And now we are going to the next function. F of x is equal to the greatest integer of x minus 1. So what we are doing here, we're going in the first just in one segment, what we have closed open, but this one tells us this function is moving. The parent function of the greatest integer function is going to move 1 unit down. So it shifts 1 unit down. So what does it mean? It was here, and if it moving 1 unit down, it was closed and open. The other side was open. And here is a closed. So it's very easy. We are just following the rules of the transformation of the functions in general. And we know what is the parent function here, and everything else is easy. And same thing is in the other side. And I think this is enough, so we don't need any more. So let's go to another function. We have x minus 2 minus 1. So we already know whatever is inside this brackets is going to move horizontally 2 units on the right and 1 unit down. Whatever I have this is the first step function in the first interval 0 to 1. I'm going to go 2 units to the right, 1, 2, and 1 unit down. So this is what it is. Here is closed and here is open. And now here is a closed and the other side is open. Here is a closed and here is open. So this process continues step by step. Here is a closed and here is going to be open. So this process continues. Same way goes in the other side. Just let me take here one eraser because I think I made it looks like a closed. Open, closed, open, closed, and this process continues. So now we are looking in the other side. F of x is inside the brackets is x plus 1 plus 2. So this is going to move the parent function, the closed interval from 0 to 1 is going to move 1 unit here. And is going 2 units up. 1, 2 up. So here is a closed and here is open. Here is a close, here is a close, and here is open. And this side is closed, in the other side, because this is a Floor function, in the beginning always they should be closed, and at the end is going to be open. So the floor and ceiling is open. The floor is closed. That's why we call this a floor function. And this process continues. So, and let's go to another question when we have, for example, the stretching or compression vertical factor in the front here. Here what we have is the parent function is going to be in the same what it was here, same position, but it's going just to stretch this factor. This step function is going to stretch for 2 units. I have 1, 2, and you see stretches for 2 units. And goes 2 units here, closed, and the other side is open. Same thing here. Here go 2 units down, open, closed, 2 units down, open, closed. And now if we have just one thing here, just to mention what we learned before in other functions. On transformation, whenever we have this factor in the front, if it's greater than 1, we have a vertical stretch. If the number here is less than 1, we have a compression, vertical compression. But in this case, 2 is greater than 1. That's why we have the stretch of the function. And now here we have f of x. Let's say here is a y. Okay, and the other side is a x. And here we have the number 4 is inside the bracket 4x. What's happening here is if the number is greater than 1, we have a horizontal compression. If the number here is smaller than 1, we have a horizontal stretch. But in this case, we have a compression. Because it's a 4, it means for 4 times the number, the interval, open-closed interval in the step function is going to decrease or to shrink or to compress. For example, here is from 0 to 5, and the first is going for 0.25. This means for 1/4 is going here, and the second one here I have a closed, up to half here is open, and here is a closed, and it goes to 0.75. It's open to 0.75, but here it goes okay vertically. We don't have any vertical stretch. That's why it goes in unit 1, 2, 3, etc. But horizontally, because it has a stretch horizontally, here is going to compress this kind of the function. Here is closed, and here is open. Here is 1. Probably you can see it. Here is 1, and same thing from here. Here is open, and to 0.25 goes closed, and from 0.25 to half here goes open, and this open is here, goes to the half, and to number 4 here goes closed, open. So this is how we can graph this function here. And let me say here already I gave you the answer. For example, here if we have is 1.5, it means we have here I said that if this number is here is smaller than 1, then we have a horizontal stretch, and because it's 1.5, then we have 2 times here we have the stretch of this function, or the function horizontally here. You see here from 0 to 2, and 1 goes from 2 to 4, and this pattern continues in the other side. If this function is, for example, whenever it is smaller than 1, we have a horizontal stretch. If it's greater than 1, we have, as we saw in the previous example, we have a shrink of the step function, or if we are horizontally, or we can call a compression, whatever is more convenient, but it has the same meaning.